We're gonna move on to part 3 of our video lesson now. Previously, we looked at where liquid pressure comes from, and liquid pressure comes from the weight of the overlying liquid on top of a certain point inside that liquid. So the deeper you go, the more liquid that's on top of you, the more pressure you will feel exerted on you. Now, liquid pressure can be calculated using this formula here. P, which stands for pressure, is equal to rho G H. So rho, that is a Greek letter. You write it down like this, sort of like a E with a long tail. And that stands for the density. G is the gravitational field strength, and H is the height of that point. So let's do some example. For example 4, it reads, the diagram shows a tank partially filled with water. Find the water pressure at the surface of the water. So at the surface of the water, so here, what is the pressure? So what's the depth at this point? The depth is 0. So pressure at the surface of the water is 0 Pascal. Okay, so in other words, when you're at the surface of the water doesn't exert any pressure on you whatsoever, only when you dive into the water. B, what is the pressure at the bottom of the water? So at this point here, what is the pressure? So pressure is equal to rho GH. Rho is the density. What is the density of water? This one you have to remember. The density of water is 1000 kilogram per meter cube. What is the gravitational field strength on Earth? That is 10. That is a number that you also should know. And what's the height or what's the depth at this point in the water? And that is 2 meters. So that's given in the question there. So you solve everything and you get 20,000 Pascal. And that's the answer. Example 5. A block of wood is pushed into the water. What is the liquid pressure at the top of the block of wood? So let's use this equation again. The density of water is 1000 kilograms per meters cube. G is 10, always on Earth. And what's the depth of the block of wood? So on top of the block of wood, it's right here, this level here. So that's A. And at point A, the depth is 1. So the pressure at that point is 10,000 Pascal. Let's do B now. We use the same formula. Density is still the same because this is still water. Gravitational field strength is still the same. Now we want to know the pressure at the bottom of the wood. So at this point here, at point B. So at that point, what is the depth? The depth is 1.5 meters, and that will give us 15,000 Pascal. Now, from the formula, you can tell that the pressure of liquid depends on 3 factors: the density, the depth, and also the gravitational field strength. So P is equal to rho GH. This is where these 3 factors come from. Now let's think about the density. So here you have 2 water tanks filled with different liquids. Tank number 1 is filled with water, and tank number 2 is filled with honey. At which point A or B has higher pressure. So A and B, they have the same height or they have the same depth. The difference between these two is that water has a lower density of 1 gram per centimeter cube, whereas honey has a higher density, 1.42 grams per centimeter cube. Which one of these will exert a higher pressure? The answer is tank B, because honey has greater density. So the denser the liquid, the more pressure that it exerts on a point in that liquid. So here we have water containers of different shapes. At which position A, B, C, D, or E has the greatest pressure? So what's the answer for this one? The answer for this one is none of them. they all have the same pressure. So remember, pressure does not depend on the shape of the liquid container. Pressure depends on only density of the liquid, the gravitational field strength, and the depth. So pressure depends on the depth. Since all of them are at the same depth, all points have the same pressure. So it doesn't matter what's the shape of the container of the liquid is. All that matters is the depth, density, and also the gravitational field strength. Here we have a glass of water that is leaking on Earth. At the same time, a glass of water is also leaking on the moon. Which glass of water has less water coming out from it? So these two holes are the same depth or the same height, and they're both water, so they both have the same density. The difference is one is on Earth, and that on Earth we have a gravitational field strength of 10. On the moon, we have a weaker gravitational field strength, 1.67. So between these 2 points, which one has a weaker pressure and will cause less water to come out from the hole? And the answer to this is the moon has a lower gravitational field strength. Oh, there's a typo here. It shouldn't be GPE. It should be gravitational field strength, GFS. So the moon has a lower gravitational field strength, so the water pressure is lower there. Since the water pressure is lower inside the glass, less water leaks out. Okay, so we looked at how to calculate pressure, and also we looked at the factors that affect pressure. Remember, the formula to calculate liquid pressure is this one here. Pressure is equal to rho GH, and also pressure depends on 3 factors, and it depends on the depth, the density, and also the gravitational field strength. In the next video lesson, we're going to look at a different type of pressure. Next time, we're going to look at atmospheric pressure.